A recent survey indicated that the average amount spent for breakfast by business managers was $7.58, with a standard deviation of 42 cents. It was felt that breakfasts on the West Coast were higher than $7.58. A sample, so now we do a sample of 81 business managers on the West Coast, had an average breakfast cost, so that's the average of the sample, $7.65. Alpha is 0.05. We want to know the critical value. Okay. So we need to determine if this is a z-test or a t-test. This standard deviation that we're given, it's not our sample standard deviation. It's not the standard deviation of this sample. That's the population standard deviation. It's the population of all the business managers. Okay, so this is going to be a z-test. Because we have the population standard deviation, this will be a z-test. So we have a z-test. Well, let's state the null and alternative hypotheses. Let's give step one of this process. So, again, the null hypothesis is always a statement of equality. And the alternative hypothesis we're talking about, let me write that better than that. I don't like the way that looks. The alternative hypothesis, so it's felt that breakfasts on the West Coast were greater than $7.58. And that's the claim. Breakfasts were higher than $7.58. So the null hypothesis is that didn't change from this survey that was taken, right? The null hypothesis is that the population mean hasn't changed. The population mean is still $7.58 at the time that we took this sample. Still $7.58. Second step of the hypothesis testing process. And where am I getting these steps from? If you go to your formula sheet, third or fourth page maybe, fourth page, procedure table for solving hypothesis testing problems. We've got the traditional method and the p-value method. You'll see both of them later on in some other questions, right? But so the traditional method, state the hypotheses and identify the claim. That's what we did here. And the second step is find the critical values from the appropriate table. That's what we're doing now. That's what is going to answer the question. So at alpha is 0.05. And this is a test. The claim is just one tail because it's like this here. Which is normally distributed. We're going to assume that. That is 81. It's greater than 30. We want greater than $7.58. So here. This is a one-tail test. This is a right-tail test. So when we find that critical value, we'll know what this z-value is here. That'll help us determine our rejection region, our non-rejection region. So let's go to the formula sheet. 0.05 is alpha, one-tailed. And again, to do that, I'm going to use that t distribution, not the z distribution table, the t distribution table, because it lays it out very nicely. Look, one-tailed, alpha is 0.05, right? One-tailed, 0.05, go all the way to the bottom for z. 1.645. 1.645. Again, one-tailed, alpha is 0.05, all the way down the bottom for z, 1.645. So this critical value is 1.645. I'll call it 1.65. So the critical value, or the critical z critical, sometimes you'll see it listed at, is 1.65. And that's the answer to the question. Third step, you would find the test value. And then the fourth step, you would determine if you reject the null hypothesis or do not reject the null hypothesis, right? So that's your steps.